Got to give the people, give the people what they want. Oh yeah, look at that, look at that, look at that. All right, let's get this. 4.5, period change and negative A values, all right? So, the normal period, which is the time for a full rotation around that circle, of a circle is 2 pi, which you all know. So, here's the thing that you got to remember. All the transformations of a unit circle. So, y equals A times sine or cosine or tangent or whatever, bx minus h plus k. A lot of this should look familiar. A is your amplitude. That's your A value. Stretches or compresses, right? It changes the radius. B is the period, which we're going to talk about in this one. H and K look familiar. H moves it left and right, which you have seen. K moves it up and down, which you have seen. One thing to notice is you might see the K value in the very front of this equation as well. So that's the thing that you'll probably see in class sometimes. All right. So when we have an equation like y equals 3 cosine of x, on this equation, the b value is 1. So far we haven't seen the b value because the b value is always 1. What we're going to talk about is what happens when the b value is different than 1. So now let's make some more connections. Since I know the period of this equation is 2 pi, this means that to find the period of an equation, I always have to take 2 pi and divide it by b, right? That's going to give me the actual period, right? So we haven't really had to calculate this before since b value has always been 1, but now we will, right? Because we always just know, oh, the period is 2 pi, and it's and nowhere do we ever see 2 pi in that equation. But since b was 1, well, 2 pi divided by 1 is just 2 pi. So we've never had to calculate the period before, but now we're going to have to do that. All right, so let's take an example of this. So find the period for y equals the sine of 2x. So you're like, okay, well, I know to calculate the period, I have to take 2 pi, always, and divide it by 2. That's going to give me the actual period. So in this case, 2 pi divided by 2, the actual period of this is going to be pi. So this means that a full rotation around this circle happens in pi instead of 2 pi. All right, so go ahead and copy the top of this down. So let's say we have y equals the sine of 2x. And I'm just gonna, and you should probably draw a little unit circle right here. So we know this is a unit circle, and it's the sine of 2x. So if I draw the regular rotation around it, right? I go from 1 to negative 1. We have the period of 2 pi, and we have the 4 stops at 3/2 pi, pi, pi over 2. Right, so we have all of our stops. But since we have the sine of 2x, right, this means I need to take my new period and divide it into 4 parts. Right, so let's actually go back. Right, we had our b value, the period was 2. So if I take 2 pi and divide it by b, and remember, b in this case was 2, I get a period of pi. All right, so you're going to draw a new circle down here. This means my full circle rotates in this piece right here, okay? So the full circle rotates in pi. So what I have to do is now I have to break just this part into 4 pieces so I can get my 4 stops. All right, so if this is, I probably shouldn't have did that. All right, I'm going to do this. This is where my full rotation starts. So now I still need the 4 spots. So I need to break this, right? I need to take pi and divide it into 4 pieces. So this is pi over 4. This is 1/2 pi. That's 2 pi's over 4. This is 3 pi over 4, right? I still need the same 4 stops around that circle. And now I'm going to graph it. But here's the important part. So now I got to think of the unit circle as stops around the wheel. The angles aren't going to match anymore. So what am I taking? I am taking sine of 2x. So I'm going to start off by looking at this unit circle right here. And I'm going to remember that what? Well, sine is the distance from the ground. So I'm going to start here. This is my first stop. At this first stop, my distance from the ground is what? You should be like 0. So at 0, my distance from the ground is 0. So I'm graphing that point. All right. So now I'm moving up here at my second stop, which used to be called pi over 2. My distance from the ground is 1. So boom. There's my second stop. Notice pi over 4 doesn't match pi over 2. Like I told you, they're not going to match anymore. So I got to think of it as stops. But my distance from the ground at that point is 1. So now I'm going to go to my second stop right here. And my distance from the ground is 0. Second stop, distance from the ground, 0. Now I'm going to go to my third stop right here. My distance from the ground, I'm underground. So it is -1. Third stop, -1. And finally, I go to my fourth stop. My distance from the ground is I'm back on the ground. Boom. So, right, in this one, I have a curve that moves faster. We get through the whole cycle in just 1 period of rotation, okay? And it happens in pi. That means if we cycled again, the same thing would happen over again, right? So this is the period of pi, okay? And we're going to do a lot of work with this, but I just wanted you to get the idea first. Now let's move to the next thing, which is negative a values, okay? So if I have a negative a value, this is when the a value is negative. This is like traveling in the opposite direction around the circle. That's how you can visualize it, right? So for example, if I had y equals -1 sine of x, remember this is the a value and it's negative. Remember when the a value like flips it upside down, or the negative flips it upside down, in this case the negative means rotate the other direction. Please recognize again, your angles aren't going to match. My period is still 2 pi. Nothing has changed about that. This is basically just the unit circle, but it's going in the negative direction. So let's go ahead and draw this. Boom. Oh, I shouldn't have did it like that. Let's draw it like this. Boom. 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 We're going to have 0. We're going to have pi. We're going to have 2 pi. We're going to have 3/2 pi. And we're going to have pi over 2. Okay, so I'm just doing my unit circle. This is 1. This is -1. But now, remember, my angles aren't going to match, but I'm going to think of it like stops in the negative direction. So, doom, 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 doom. My first stop, if we're doing sine, again, so my distance from the ground, I'm underground. So now I'm going to trip in, my bad, sorry. My first stop is at 0. My starting point is at 0. My sine is on the ground. So my starting point is still 0. Thank you. My first stop, Going in the negative direction puts me now underground. So my first stop is underground. So I'm at -1. I'm at -1, which is right here. My second stop is back on the ground, which is right here. My third stop is at 1 above the ground, which is right here. And my fourth stop is back on the ground, right here. So now, if I'm going in the negative direction, it just kind of flips it over, just like we would have known before. All right. So again, these are just to make sure this gets in your head early. We're going to practice it a lot, but it makes it way easier for me to teach you when you have seen this stuff once before. Mr. Bass, I'm out. Peace.